I really enjoyed the previous presenter. So thanks for being here and listening to the collective wisdom of folks. I work with USA Volleyball as chief of sport, and in that capacity, I am responsible for the supervision and oversight of our national teams across indoor, beach, and our Paralympic discipline, which is called sitting volleyball. I also lead our education services department and our high potential youth development platform called the National Team Development Program. So while Ron had mentioned that there are things that we would certainly be interested in, from learning how to amplify some of the recent success and increase publicity of volleyball, particularly women's collegiate volleyball in the US and beyond. My focus here is going to be more on the performance side of the house, which is really where my background comes from. I have a PhD in a field called biomechanics. That's how we understand how the body moves and how we can hopefully optimize movement to improve performance or reduce injury. And with that said, I'm just going to jump in. I suppose before I start, I'll say this about USA Volleyball. We are one of 40 national governing bodies that reside in the U.S. that are responsible for fielding our Olympic and Paralympic teams. Like the U.S. Olympic Committee, it's sometimes surprising for those that don't know, but the U.S. Olympic Committee and Paralympic Committee is not supported by any government funds. Congress doesn't allocate money. We don't have a national lottery type of program that some of the countries have. It is all supported by private and public donations and corporate sponsorship. USA Volleyball is a smaller version of the U.S. Olympic and Paralympic Committee, a nonprofit organization that fields our Olympic teams and Paralympic teams. It was responsible for grassroots membership, tournaments, etc. So what I'm going to show you is I think much less sophisticated than some of the things that the earlier presenters have described, but I can show you kind of where we are in our journey along this, and I welcome any of you that are much more advanced than us to chime in and let me know how your expertise might come to bear with some of the things we're trying to do. Olympic and Paralympic volleyball is incredibly competitive, especially at the really pointy end of the international competitive spectrum. This is just a very quick snapshot of World Championship and Olympic Games indoor volleyball matches over the past 6 years. And this shows in these tournaments that the average, or I guess it's a frequency distribution of the final set score outcome. In volleyball, you have to win a set by 2 points. Most indoor volleyball is a game to 25, so you can win 25-23. But if it's 24-23 and the opponent ties it up at 24-24, it's going to go at least to 26-24. And what you see in this is that over 20% of all of these matches at the highest levels of competition are decided by 2 points, next most by 3 points. And in the 2021 Tokyo Olympic Games, our men's national team, which entered the tournament ranked third in the world, actually didn't advance out of pool play. We played 18 sets in total, and 9 of those, 50% of them, were decided by exactly 2 points. So it's incredibly competitive, and it's incredibly fast. If you haven't watched high-level volleyball, either men's or women's indoor particularly, it is remarkably violent and awesome. It's so fast. It's so remarkably challenging to see that these athletes are doing the things that they can do at the speeds that the game is played at. This little inset here is now one of these machine vision-based technologies. This particular slide is from Hawkeye. The current technology being used now in Volleyball Nations League is from a company called Bolt 6. But these are actually providing real-time in versus out calls with balls that are moving well in excess of 60 miles an hour. So you can see by the margins here that this particular ball was called in with just a fraction of it in. The red and white are in, the blue is out. This ball just barely touched the white, it's in, and the point was awarded to the team that hit this. But these are the margins of the game at the highest levels that they're played. So anything that I'm going to present here is kind of in the context of this. This is the primitive version of match analysis on the right. This is just from maybe a decade or so ago, where coaches were scribbling notes and trying to keep track of things with one of the multicolored pens. and trying to identify what athletes were doing what and where, what were their tendencies. And while I can applaud the effort in doing this, it's clearly really difficult to keep track of it, let alone use and create a data repository that can be drawn upon for subsequent analysis. I included this slide with this AI generated analyst. I thought it was actually, on one hand, quite good, on the other hand, quite funny, in that they're the only coach or analyst on this very long row of seats next to the court. And of course, as an analyst, they're not paying attention to anything that's happening on the court. So just kind of an interesting example of how good and not so good some of these things are at this point. Fortunately, technologies for basic levels of match analysis, these are done for both our team as well as every international team that we might play in the future. They're also done for all of our national team athletes that spend most of their year competing for professional teams abroad. There are no major professional leagues for men's indoor volleyball in the United States. And while that's changed, there are now going to be 3 indoor professional leagues for women. Those are all in relatively young forms of their evolution. So this is a very typical match analysis software tool. There are 2 here represented here, one on the left from a company called VolleyStation, one on the right from a company called Huddle. All of these things are done with analysts providing computer input notation, describing where something happened, what specifically happened, who did it, what was the outcome, and those are tracked over time. It's nice now that not only can we gain access to this and we can do this on a point-by-point, set-by-set, match-by-match basis, but we can also do it over the course of an entire season. We can then store those and look at those for either the next major tournament or prepare for the next season. All of these can be tied to specific videos that are taken of these, and the starting and stopping of any given input to define an event is captured and categorized so that there's kind of an automatic highlight reel that can be generated for any particular skill of any player of any team in the world. And so that ends up being a really productive tool. Our coaches can then use this to communicate back and forth with athletes about particular skill performance or other areas of development. This is an example of the VolleyStation technology, actually the heat map, which is just showing the primary tendencies of where hitters tend to hit balls in particular formations. This is now overlaid on video, which I'm sure many of you can appreciate that the magnitude of information that our coaches are generating about each player, not only on our team, but on opponents' teams, is really complex. It not only varies as a function of the 6 different rotations that players go through on the court in the course of playing, but also over the course of sets, matches, tournaments, seasons, and trying to boil all these things down to present a cohesive and concise description for our players as we prepare for international competition is a really complex proposition. And one of the things that we're really working on is how to make that information more understandable, and ultimately for the purpose of being able to allow that athlete to not only hear it, but understand it and know how to put that information into play while they're actually competing on the court at very high speeds. The previous presenter showed an example of technology that's being used in professional sports, in the NBA particularly. That technology has obviously been advanced through international football, soccer, American football, now professional basketball, even getting into collegiate game at this level, tennis, and hockey, and you name it. So unfortunately, volleyball is not a big money sport. It is very popular in some countries around the world. It's gaining popularity in the US. But at the highest levels of play, it's not a commercially successful sport from a broadcast perspective, at least, from an American broadcaster's perspective. So getting access to some of the tools that you're seeing being deployed in the NBA or NFL or Premier League, for example, take longer to kind of trickle down through Olympic sports that simply don't have kind of command the same audience sizes. We've actually engaged in a grant via the U.S. Olympic and Paralympic Committee Technology and Innovation Program to employ these machine vision and AI technologies to track the player and ball. And the purpose in this is to try to understand exactly where everybody is at each instant in time, but particularly at the instant where things happen, like a serve is struck, a ball is passed, an attack is hit. And in doing so, we can better understand not only how to bring those heat charts into more direct relevance, but dramatically improve kind of the spatial resolution of those. This just shows, and hopefully it's playing okay for you, the machine vision's attempt to track and bound each player and the ball. This is at real speed in a real match from a real camera view. The two-dimensional projection of players is indicated on the right. It's counting the number of touches, it's estimating the position, and that's kind of as a projection of a three-dimensional thing onto a two-dimensional plane. And there's a lot of noise in this. There's some real challenges in terms of the tracking accuracy and the resolution to be able to use this effectively. We're making progress. Unfortunately, we're not quite there yet. So if you do this, or if you know people in the machine vision space that can do this really, really well, please let me know, because we're looking to establish a new partnership to continue this work. In terms of some of the other technologies that are used in elite performance, I'll just demonstrate a couple of these here, just to kind of show the sources of technology that are providing us with data, and then some of the more rudimentary ways that we're using this data in supporting elite athlete performance. The rectangles that this gentleman is standing on are called force plates. Just think of them as really expensive but sophisticated bathroom scales. And they're measuring forces at up to 1,000 samples per second. These particular devices, we're measuring independent left and right leg forces directly. These data are sampled at, again, anywhere between typically 500 and 1,000 hertz. And I'm just going to show an example to kind of differentiate between how athletes can generate force differently, but how that translates into performance, and then what we actually do with this. This is the same athlete, and on one side, these are synchronized to the start of motion, but they're showing essentially a fast jumper on the left and a slow jumper on the right. Well, based on basic laws of mechanics, we know that the product or the summation of forces applied against the ground that end up getting transferred back to the body over the time over which those forces apply provides a measure of called impulse. And impulse is directly related to the ability to generate velocity or change velocity. So from the ability to measure instantaneous forces that this individual is applying against the ground, we can not only understand how long it takes them to get themselves off the ground, but we can also accurately understand how high the center of mass of the body actually was elevated into the air. In this case, even though on one hand, the athlete moved relatively quickly, that is, that whole sequence on the left took 650 milliseconds, and one athlete actually generated force over a much longer period, in this case, almost a second. That in fact, just because of the laws of mechanics, we can actually show that the elevation of the center of mass of these two athletes is almost identical. And so that's useful in some ways, because being able to get off the ground is a really important attribute in sports like volleyball, as it is in basketball and other sports. But being able to do that quickly is also important, because it allows more time for accurate decisions to be made about which direction do I go to execute a block, or how can I get off the ground quickly to attack a ball that maybe wasn't perfectly positioned. So this information can then be sucked down into analyses, and these are just representative to show that we can look at a team-wide average. We can identify athletes that are maybe well beyond the group average. We can then look at each athlete's tendencies in a more longitudinal manner. And from this, we can assess not only how does this athlete tend to jump, but how do they respond to the various training interventions that now we want to apply? So can we make a slow jumper faster? Can we make a fast jumper fast at the end of a match where they may be very fast twitch and fatigue oriented? How can we allow them to kind of extend their explosiveness for longer periods of time? A technology that's been around for some time, but that we've just deployed over the past couple of years is this particular technology. This is from a company called Catapult. There are many vendors of these kinds of technologies. This is essentially an inertial and gyroscopic sensor that provides us with the ability to not only measure accelerations in 3 dimensions, but also the rotations of the sensor in 3 dimensions. And we can do this live in competition. We can use it in training, and it allows us to do things like simply assess the number of jumps that an athlete takes, but we can actually extend that now to look at the aggressiveness of those jumps, the intensity of movement, and we can now do that across different directions. So it's not only vertical that we're limited to, but now we're looking at horizontal and sideways accelerations as well. That information ends up being really useful, and we can use this with each athlete, and we can develop libraries or catalogs of drills and activities, including competitive matches, and look at the actual load intensity of those activities. We can do this in a rolled up fashion. So this is just, I think, the top 15 activities that our women's indoor national team experiences over time. We see that a drill called escape room, which is a really competitive scrimmage type activity, actually is the most intense of all, at least for our liberos. We can do this by position. We can do this by individual player. We can do this in a way that lets us understand what are the collective intensities in any given match or across an entire match. We can do this across a season. And this allows us to, first and foremost, understand what are the actual physical demands that athletes experience by position, and in some cases by individual, in high-level international competitive matches. And by using that and knowing how many competitive international matches there are in a tournament, we can say that our target intensity for the Olympic Games is going to be about this in terms of intensity. And we can use that information then to guide week by week, day by day adjustments to our training volume and intensity, so that we are not only really well prepared for the intensity that we're going to face in the most important tournament of the year, but we're also going to do that in a way that we can kind of peak at the right time during the year. There's an international competition going on right now. It's called the Volleyball Nations League. We have been using this as a way to kind of vet some of the rosters and the Olympic team selection process, particularly for our women. But in that tournament, we're using that to essentially get ourselves more prepared for the most important tournament in the Olympic Games later this summer. As mentioned, these can be broken out by individual athlete, and each column here is an athlete. I've de-identified these just for privacy, but the dots indicate a day's worth of intensity. And so over the course of a national team season, we're able to track not only what athletes are doing specifically, but also what they're doing by position, and we can appropriately tailor our training interventions and rehabilitation to these things. The nice thing about this technology as well is it has allowed us to actually monitor athlete load while they're competing with their professional teams in international leagues. That's a first for us over the past 2 years, and we've been, I think, pretty successful in getting compliance from the athletes in doing that. I think they're seeing the value of that and coming back with not only our sports medicine staff have a better understanding of what did you experience last year and where are you physically, but now we actually have a much more informed starting point that our rebuilding to national team level intensities can be that much more informed. Interestingly, these sensors, we've recently completed a pilot study with our sitting athletes, and I've just included the link here. They're actually our women's team, which has won back-to-back gold medals, last two Olympic Games. They're going for a three-peat this year in Paris. They have been the number one ranked team in the world for the past decade or so. It's an amazing sport to watch if you've never seen it. That link there is actually to a match that's probably happening live right now against China, which is the number two team in the world. So if you haven't seen it before, check it out. But we use these sensors to try to understand the propulsive loads these athletes experience while they move themselves along the floor. In sitting volleyball, you have to stay seated. Literally, there's a violation that is expressed like this, where your butt comes off the ground. So it's unique in that the ability to move around the floor is totally done by their arms and legs. Athletes that are competing in this sport have some level of physical disability. Many of our athletes have lost a limb either due to accidents or cancer or military action. Some from other genetic issues, but what we've done is we've used these same sensors to try to understand these movement profiles of athletes, again, individual, but also by position. And we're noticing that these are now kind of the two-dimensional projections of acceleration load for three different athletes over the course of a tournament. And what we can see by this is that certain athletes tend to move explosively in different directions more often. This information can now be used by our strength and conditioning and sports medicine staff to not only better prepare these athletes through very specific, individualized direction profile training programs, but we can also be more informed about our rehabilitation needs as well. So this is just a novel application of these sensors, and we look to extend this project going forward toward the LA Games in 28. We have been dabbling in AI, and I'm going to just show two quick examples of this. One is that I'm really fortunate in that we've got some remarkable coaches in Team USA. Our head coaches for the men's and women's indoor teams, as well as our coaches for sitting volleyball, do an outstanding job of capturing information from the entire coaching staff and our performance staff after a tournament. These typically take a very long form. Our staff are given access to a Google Doc or a doc that's put in Teams. They provide their own input based on their own perspectives of what they thought about particular aspects of the team's readiness. It could be, physical preparation, could be roster selection, it could be the management of timeouts, it could be things related to travel logistics or other things, health, well-being, nutrition, hydration, etc. So all of that input is captured, and I'm really grateful that our staffs have embraced this process because it's important. But the processing of these documents, these debrief documents, and kind of looking at it the other side, we do these pre-mortem exercises in advance of major competitions like the Olympic Games, same kind of thing, but more of an indication of what do we think might go wrong and what can we do to prevent or mitigate those issues. But this particular debrief document was from last year's Volleyball Nations League tournament, and it was 22 pages long. And typically the way this would go is that myself and the head coach would spend anywhere between a few days or a week reading these multiple times, trying to extract common themes, trying to then develop meaningful actions that can come out of these, and then prioritizing those for the next season or for the next tournament. And what we've been able to do is feed these into tools like Claude or ChatGPT and ask them to summarize these. And so a process now that had taken in the past, the post-Tokyo debrief, for example, took me, I think, well over 10 days, that now I can actually do all of that work in less than 5 minutes. We've done the due diligence of actually comparing the coach recommendations or the coach insights with what the AI tool is generating. And quite frankly, at this point, we're now just prepared to almost move on with the tool directly as the primary source with some added color commentary to add flavor into interpreting that. But it's a remarkably powerful tool. We've used this kind of thing for not only the debriefs, but the pre-mortems. It's a huge time saver for us and lets us execute upon the plan and the action steps rather than spend so much time going through them and trying to figure out what was everybody saying. When we get through these debriefs, by the way, one of the things that inevitably comes up is we need to intervene with psychology. We need to do pressure training. We need to work on nutrition. We need to do various things related to sustaining our power generation. And what I've been able to do is go through those reports, ask for now detailed examples from the literature of how do you justify this, or provide me with some evidence that can show the magnitude of the effects of these interventions on athlete performance. And the nice thing is that while certainly early versions of some of these tools were really bad with creating articles, peer-reviewed articles that sounded like they were legitimate, in fact, many times they were just hallucinations. We've been able to now take those, improve upon the accuracy of that, but now we use tools like litmaps to, if we start someplace and find a paper of particular interest, we can use a tool like litmaps to now gain a much faster access to related articles, kind of cross-cited articles, and reach out to some of these experts directly to bring their insights to bear. Last, I'll just mention some examples that we've done on the analysis side. The top left chart here indicates the relationship between a method of evaluating international competitiveness. We use a method called ELO. We've used other, but ELO is pretty robust, very easy to explain. The horizontal axis is the ELO rating of men's beach volleyball teams. And the vertical axis represents the statistical likelihood of a team with a particular ELO rating winning a medal at the next major competition. That work was initiated by my team at the U.S. Olympic and Paralympic Committee in about 2013. I've since extended it for use with USA Volleyball, but it provides us with a really powerful way to understand where are our teams specifically relative to the top teams in the world, and what are the likelihoods of us being able to medal at the next games. Obviously, the most important ones for us next are the Olympic Games in Paris. These particular data, I'm just going to show kind of the evolution of this in two steps. We had the raw ELO data expressing that as the function of medal expectancy. That's actually done with a Monte Carlo simulation to try to provide that relationship, but it also lends itself to a logistic regression, which is fit below. Now, even with a PhD in a field like biomechanics, it's been quite some time since I've done some of those coding exercises by hand or myself, and so I was thrilled to be able to put this into ChatGPT, ask it questions, and have it essentially not only do the analysis for me, plot what I wanted to see exactly the way I wanted to see it, but also provide me access to the code that then I can use myself, and I don't have to relearn how to code or learn how to code Python for the first time. So this has been super powerful and super fast, and has let us kind of gain an additional level of insight and objective analysis that previously was much more difficult to come by. And that's it. So I'm happy to answer questions, but I'm also happy to hear from any of you that have tools or expertise that could be brought to bear in some of the things that we're doing here. So thank you.